Alright, let's talk about classification of organic compounds. So organic compounds are grouped into two major categories: hydrocarbons and hydrocarbon derivatives. First up, hydrocarbons. These guys are simple. They are made up of only carbon and hydrogen atoms. That's it. Just those two elements hanging out together, forming various structures. So check out these diagrams of hydrocarbons. Simple, right? Just carbon and hydrogen. Now, hydrocarbon derivatives take it up a notch. Imagine a hydrocarbon where one or more of its hydrogen atoms gets swapped out for something else, maybe an oxygen, a nitrogen, or even a halogen like chlorine or bromine. That gives you a hydrocarbon derivative. Some common examples of hydrocarbon derivatives include alcohols, where an OH group replaces a hydrogen atom; carboxylic acid, where a COOH group steps in; and amines, where a nitrogen group, that is NH2, takes over. You also get halogenated hydrocarbons, where hydrogens are replaced by halogens like chlorine, fluorine, bromine, or iodine. But hydrocarbons themselves are further divided into two types: aliphatic hydrocarbons and aromatic hydrocarbons. For aliphatic hydrocarbons, they are super flexible. They come in different flavors, either straight chains, branch chains, or even non-aromatic rings. The aliphatic ones can either be open chain hydrocarbons, which are exactly what they sound like, open, yes, unclosed chains, or they can form cyclic hydrocarbons, where the carbon atoms join up to form a ring. Now, open chain hydrocarbons can be further split into saturated hydrocarbons, which means no double or triple bond, just single bonds all the way, and unsaturated hydrocarbons, which do have double or triple bonds. The saturated ones are called alkanes, like methane and ethane, just simple single bonds. Then you have alkenes, like ethene, which have at least one double bond. And lastly, there are alkynes, like ethine, which comes with a triple bond. And for those fancy cyclic hydrocarbons, well, cyclohexane is a saturated cyclic hydrocarbon. No double bonds here, but something like cyclohexane is unsaturated because of that double bond in the ring. Next up in the other big category is aromatic hydrocarbons. These are special. They are built on a unique structure, usually involving the famous benzene ring. That's 6 carbon atoms in a ring, each connected by alternating single and double bonds. And thanks to COOH, aromatic hydrocarbons have a stability that other hydrocarbons can only dream of. So compounds like benzene or toluene are part of this group. Their chemical properties make them stand out. So to sum it up, hydrocarbons are divided into aliphatic, which include open chain and cyclic forms, and aromatic groups. Aliphatic hydrocarbons can be saturated like alkanes or unsaturated like alkenes and alkynes, while aromatic hydrocarbons feature that distinctive benzene ring structure. And hydrocarbon derivatives, well, they come from replacing one of those hydrogen atoms with a functional group, giving us the huge variety of organic compounds we see today. Thank you very much for tuning in with us. If you find it interesting and educational, try to subscribe to our channel, like this video, and leave a comment in the comment section below. See you in our next lesson.